Welcome to this DesignLights Consortium webinar on energy reporting. My name is Levin Knock and I will be your host. First, a few housekeeping details. We have a lot of people in the audience today, so everyone is muted. The webinar is being recorded. A video recording of the presentation and also a PDF of the slides will be posted soon at designlights.org. If you have questions about the presentation, please enter them in the GoToWebinar questions pane. I appreciate that my colleagues at DLC, Heather Jones and Jason Jeanette, are helping out today with logistics and managing the questions and answers. They will reply to some of your questions during the presentation, and also we will take questions at the end. For the agenda today, after an introduction, we'll take a look at DLC energy reporting requirements and recommendations in terms of where we started 6 years ago, where we are now, and recent developments that will impact the next steps for the future. As I mentioned, we will address some questions from the question window as we go along, and then have time for more questions at the end of the presentation. I am presenting this webinar based on my experience in developing the DLC technical requirements for network lighting controls. In particular, the section on energy monitoring has been under development ever since we launched the Network Lighting Controls Qualified Products List in 2016. Before joining the DLC, I worked on energy savings from LED lights and lighting controls for 5 years as a contractor at Bonneville Power Administration in their energy efficiency program. Before that, I worked in various organizations in market research on energy savings in commercial buildings and in product research and development. I have a bachelor's degree in physics from Cornell and a PhD in adaptive imaging from Duke. Speaking of Duke University, long ago when I was in grad school in North Carolina, I used to enjoy contradancing. This is a bit like square dancing, except instead of lining up in squares, the dancers line up in long lines across a dance hall. The dances consist of a series of standardized dance moves, where a caller yells out each move to do next, and then everybody does the same dance move. So when it goes well, you can have a great big room full of lots of people all moving around quite vigorously without anybody crashing into anybody else. This is only possible because everyone there agrees, more or less, on how to do a do-si-do or an allemande, and everyone agrees on which is your right hand and which is your left. When everyone agrees on a standard set of words to describe a standard set of motions, the dances flow smoothly and they're a lot of fun. And that is a brief introduction to the joy of standards. Which brings us to the DesignLights Consortium, or DLC. The DLC helps our member efficiency programs and industry partners work together more smoothly. If every efficiency program had unique requirements about what kind of product can qualify for efficiency incentives, then most manufacturers could only afford to qualify for 1 or 2 incentive programs, not dozens of them across North America. The DLC aims to serve as an intermediary, helping efficiency programs agree on a common set of requirements so that manufacturers can meet one set of requirements and then qualify for incentives from many utilities on many different projects. I assume that most people listening are familiar with the DLC, but here's a quick refresher. The DLC is a nonprofit organization that maintains lists of qualified LED lighting and network lighting control products. These lists are used by many energy efficiency programs across North America to administer rebates and incentives. To do that, we create policies such as technical requirements describing how products can get qualified to receive those incentives. Whenever possible, in those requirements, we like to refer to standards to keep the dance moving smoothly. The DLC is not a certification body. It does not create standards, does not test products, and does not offer any rebates or incentives directly. I want to clarify a few words that I'll use in particular ways throughout this presentation. First of all, DLC stands for DesignLights Consortium, the nonprofit organization that I work for, that is not to be confused with NLC, which stands for Network Lighting Controls. One of the programs that the DLC runs is a list of NLC products qualified for efficiency incentives. Next, in the technical requirements that NLC systems must meet to be on the DLC qualified products list, the word required applies to capabilities that a system must offer. The word reported describes capabilities that are optional. Some DLC qualified systems support reported capabilities and other systems do not. When the DLC began to address this current topic back in 2016, we called it energy monitoring. The term energy monitoring refers to energy management tools embedded within an NLC system that enable various features such as real-time energy dashboards, predictive maintenance, and reports of historical energy data. More recently, we've been talking about energy reporting, which refers to computer files of historical energy data that are created using the embedded measurement tools I just mentioned, along with data processing, computer memory, and file export functions. If you didn't catch all that, no worries. In terms of how the DLC uses these terms, they basically both refer to the same general topic, which is how can we encourage more NLC systems to have the energy monitoring capability that enables energy reporting to utilities. With that background, now I can talk about the DLC requirements for network lighting controls. All of the products on the DLC list of qualified network lighting control systems offer the required capabilities listed here. Some systems also support additional control functions, such as personal tuning, color tuning, demand response, etc., that are not required by DLC. Those capabilities are reported, not required. Today, we're exploring energy monitoring, which is required for all systems except for those that only claim room-level scope, rather than a larger scope of an entire building or a portfolio of buildings. So why are network lighting controls and energy reporting important for energy efficiency? Many energy efficiency programs are interested in promoting network lighting controls as a way to save electricity. They've been incentivizing LED lights for nearly a decade. So now LED lights are so common that it's getting more difficult to claim energy savings from installing them. On the other hand, network lighting controls are not common yet, and they can save roughly half of the lighting load that's left after an LED retrofit. In addition, a networked lighting control system provides a foundation of networked and powered sensors distributed evenly throughout an occupied space, which can serve a comprehensive whole building approach to energy efficiency and can support a wide variety of applications of the Internet of Things. Here's another view of why NLC is important to energy efficiency programs. This chart shows the potential energy savings for lighting in commercial and industrial buildings across the United States projected by the U.S. Department of Energy. The orange and blue areas at the bottom are for outdoor and indoor LED lights. The solid green part at the top was business as usual, and the striped green part shows all the extra savings out to 2034 that could be achieved with aggressive utility support for network lighting controls. Given that network lighting controls are important to energy efficiency programs, why are energy reports important? First of all, a record of the energy usage from completed projects helps programs evaluate and claim incentivized energy savings with regulators. It also helps them set incentives at a level that makes sense based on the expected amount of energy savings. In addition, a record of energy savings from past NLC projects can help to forecast the energy savings from future projects. If energy reports were easily available from more NLC projects in a standard format that could be easily processed, that would help NLC incentive programs to scale up by streamlining program administration and justifying incentive amounts. So how has the DLC been promoting energy reports? Most recently, on Monday, we published a white paper describing proposed revisions to the DLC energy reporting requirements. Compared to this webinar, the paper has less context but more technical details. It's only 12 pages long, so if you'd like more details after the webinar today, please take a look. Back in 2017, we commissioned research to collect energy reports from more than 100 buildings with network lighting controls. The results provided data that several efficiency programs have used to set incentive levels and to forecast energy savings from NLC systems. In 2020, we expanded the study to nearly 200 buildings. Both of these studies showed that across this group of commercial buildings, an NLC system saves nearly half of the lighting energy on average, but the exact performance varies widely from one building to the next. In the chart shown here, with a different vertical bar for each building, the worst performing building on the right only saved about 2% of the lighting energy, while the best performing buildings on the left saved around 90%. But the main reason I mention this is that the research involved painstaking manual processing of all the energy reports, all 200 of them, because every NLC system had a different energy report format. We realized that if NLC incentives are to scale up to thousands and thousands and tens of thousands of buildings, there needs to be a consistent format for all the different energy reports to follow. In the DLC Network Lighting Control program, the capability of energy monitoring was reported, not required, from 2016 through 2018. Then in 2019, the energy monitoring capability was required for most NLC systems, with an exception for small systems that only claim a room-based scope. Also, there was a one-year grace period, so it wasn't really required until June 2020. The energy data could be in a CSV file or available through an API. Beyond that, there were no requirements for what exactly an energy report should look like. In 2020, after searching for standards to apply to energy reports, we aligned the requirements loosely with ASHRAE Energy Code 90.1, Section 8.4.3. that requires 15-minute time-stamped interval data from independent building systems. They required a data record of 3 years, but DLC shortened it to 2 years, and also recognized state change data as an alternative to interval data. Also, in the absence of a more detailed standard description of what exactly an energy report should include, the DLC provided some recommendations. And that's where we stand today, because those requirements have not been updated since June 2020. But fortunately, some standards were updated. Brief recap, the ANSI ASHRAE IES 90.1 Energy Code includes some requirements for energy monitoring by building systems such as the lighting system. In 2020, this was the only relevant standard we could find, so we took this as a foundation and modified the requirements based on stakeholder feedback to only require 2 years of data and to also accept state change data as an alternative to 15-minute interval data. In 2021, the NEMA ANSI C137 Committee on Lighting Control Systems published 2 relevant standards on the accuracy of energy reporting and on data tagging. I want to express sincere appreciation to all of the committee members who contributed to creating these standards. Both standards will be invaluable in helping the dance of efficiency incentives and NLC products to flow more smoothly. ANSI C137.5 specifies the minimum performance requirements for lighting devices that report energy data. These requirements include energy data types to be reported and the accuracy performance of those data types. Before this standard was available, the DLC was trying to inform the NLC market about the accuracy and inaccuracy of data reports from various products. Frankly, it was kind of a mess because each different product was tested and characterized in different ways. This standard will help the DLC to eventually require that all the products with energy reporting will need to offer the accuracy that is specified by the standard, that is sufficient for the needs of the incentive programs. ANSI C136 contains a controlled vocabulary of terms for lighting control systems. These terms enable the development of semantic model elements, such as data tags that facilitate the exchange of data and metadata used in control and analytics. The terms contained in this standard are intended to be used by available semantic models, such as but not limited to the future ASHRAE 223P standard, Project Haystack, and BRIC. The terms that are included support real-time interoperability for two different lighting control systems that need to work together. For instance, when the lights in two different wings of a building are controlled by NLC products from two different vendors. This is relevant here because terms for exchanging energy data are included. This will support energy reports for energy efficiency programs and also support real-time energy dashboards. In addition to those two standards released in 2021, a new standard, C137.9, is currently under development. This will provide a consistent, dynamic, and comparable way to communicate how network lighting control systems have been programmed after hardware installation and startup. This standard is needed to provide all stakeholders a means by which to understand how a lighting system or portions of it have been configured at the point in time the report is generated. The report will be exportable to a common data format. This configuration report will go hand in hand with the time-stamped interval data in the energy report to give an efficiency program a concise but comprehensive overview of the energy-saving performance of each NLC installation. In order to make progress on energy reporting, in addition to those new standards, the DLC convened a working group on energy reporting in the fall of 2021. The working group included representatives from utilities, efficiency program implementers, network lighting control manufacturers, and the Pacific Northwest National Lab. There were 4 virtual meetings in September through November of last year. I want to thank everyone involved because your active participation contributed to the success of the group. And I want to assure everyone on the call today that the proposals from this working group will go through the regular DLC stakeholder input process, so you will have multiple chances to contribute to the final outcome. We began by clarifying the use cases at efficiency programs for energy reports, and then explored how NLC energy reports can best support those use cases, along with what constraints are faced by manufacturers. We then drafted proposed revisions to the energy reporting section of the current NLC 5 technical requirements, and iterated a few times through discussion followed by revisions. Since then, over the course of this spring, I've been refining the proposals in terms of aligning with standards and exploring which changes to introduce when. We learned that efficiency programs can use energy reports for several different things, but the highest priorities are to claim the energy savings that result from their incentivized NLC projects, to set incentive amounts that they can pay for incentives for the savings, and to help forecast expected energy savings from future projects. Also, energy reports can be useful for debugging to help get a new installation running smoothly. The most critical time for data collection is in the first year after initial configuration. We also learned that energy reporting is rarely installed in the field because it frequently gets value engineered out of projects. All aspects of a requirement for energy reporting need to be tested against this constraint. In other words, a minimally viable product is much more likely to actually get installed as compared to a product that addresses many different use cases with many different features. To explain this a bit further, while the energy monitoring capability is required by the DLC to be available on non-room-based NLC systems, this capability is rarely a standard feature that's included in every installation of that product. More typically, it's an optional feature that is often omitted from projects due to value engineering. A goal of the working group was to define the minimum viable capability that will serve the primary needs of incentive programs without adding undue cost to NLC projects, so that energy reports will be available more easily from more projects. With that in mind, the DLC requirements need to demand as little as feasible from system memory, network throughput, and the longevity of the accurate metering functionality. The topics of proposed changes are summarized here. First, expand eligibility to accept 4 weeks of 15-minute data plus the first year of daily data to reduce the burden of compliance in terms of record length and of long-term maintenance of energy reporting accuracy. Next, recognize the 2 new ANSI standards and require interval data in .csv or Excel files. This is because interval data is required by ANSI C137.5, and both state change data and API data do not really fit the utility use case. And finally, revise the DLC recommendations for file contents to address essential topics while minimizing the burden of compliance. In terms of what is proposed to actually change in the NLC technical requirements, there will be a new table labeled EM0 with high-level data about what efficiency programs need. Also, the 2 existing tables, EM1 and EM2, with recommendations about the contents of an energy report, will be revised. Here's a draft of the proposed new table EM0. Starting from the top, now that there's a standard ANSI C137.5, we want to refer to that in terms of the accuracy and in terms of the type of data that is reported. The energy metric will be cumulative energy use and not energy savings. The reported unit was recommended to be kilowatt hours. There will be further discussion about this because in relation to C137.6, that makes space for kilowatt hours with a scale factor, but it's not exactly the default. So more discussion on that, but that was a proposal from the group because utilities typically work in kilowatt hours, and because they're mostly interested in groups of luminaires or zones as opposed to individual luminaires. So in terms of spatial granularity, the proposal was for a group of luminaires larger than one individual luminaire, but smaller than a whole building. And so again, there will be further discussion on exactly how to define this, probably in terms of physical space, so there are no overlapping zones where one luminaire might appear in multiple zones. The reporting format would be either CSV or Excel file. The record duration, the proposal is for the current requirement, 2 years of 15-minute interval data, or a new requirement that would use fewer system resources, where the 12 months of daily interval, up to 12 months of daily interval data would be available within the first year, and 4 weeks of 15-minute interval data for the previous 4 weeks would be available anytime during the first year. And in terms of the reporting resolution, it's basically follows C137.5. And then in terms of revising the 2 tables of recommendations, these would still be suggestions. These are not standards, and so they're only suggestions as opposed to requirements. But we would add a few parameters and remove a few other parameters and clarify some definitions with the help of the new standards. So this would be the new proposed table EM1 with the site name and the total power used by the entire lighting system. And then we'd have zone level data where each zone would have an identifying term and the quantity of luminaires in that zone and the rated power total of all the luminaires in that zone. And then this next section, configuration data, this will take a lot more discussion. We got to the end of the working group and realized this was still an open question. Basically, the efficiency programs would like to know within each zone, how is the high-end trim set, how is the occupancy vacancy set, and how is daylight harvesting set. The difficulty is that these zones, often there are different zones for different functions. For instance, the daylight zones are organized in terms of windows versus the high-end trim is more likely to be organized in terms of the room or the usage. So we've got some work to do in terms of exactly how this configuration data will be represented. And I'm hoping that the standard that's in development, C137.9, may help shed some light on this. And next, we have, this would be the proposed table EM2. So this describes the interval data. It's very simple. There's just a timestamp, the zone ID, and the kilowatt hours for the last either 15 minutes for that 4-week data or the once a day rating, once a day value for the 1-year record. So what comes next? We want to add, first of all, we plan to make one minor addition to the current NLC 5 technical requirements within the next month or two to make it easier for new products to qualify for the energy monitoring capability. Basically, this change means that an NLC system needs less memory storage capacity than before. This change seems important to implement quickly because it could support the installation of energy reporting in more actual projects. It won't go through the full DLC comment process because it will not have any effect on any of the existing qualified products. Beyond that change, all of the other proposals outlined in this presentation will be evaluated through the regular DLC policy development process, which is presented graphically here. First, we conduct research and then get advisory input. That's where I'm at now with energy reporting. Next, we write a draft policy. That policy will be distributed for open public comment and modified based on stakeholder feedback. We receive many comments which we review. After 1 or 2 iterations, probably 2 iterations for a major release like this, we finalize and release a final version. The exact timing of that next major release is still in the planning stages at the DLC at the moment. As I mentioned before, we are not a certification body, we do not write standards, and we do not require consensus to move forward. And as I mentioned, if you would like more details, there's a white paper that's now available on the DLC website. Please take a look. And a recording of this webinar will be posted soon at designlights.org/resources. And now we will go to the question and answer period to see if there are any open questions.
Yeah, Levin, we have a couple questions. Kip is interested in hearing on how monitoring and/or reporting fit into measurement and verification protocols for utilities.
Great question. Well, we've tried to, the 15-minute interval data requirement comes from the world of measurement and verification. So after typically after a efficiency program incentivizes a project, they will go back later and sample some subset of projects, maybe 5 or 10% of the projects a couple of years later, or at least 1 year later, to see if the energy savings are what they actually expected. And this is very important because if the energy savings are lower than expected, then they lose credit for those energy savings. The goal of energy reporting is that you could get a report from every single project that is incentivized. So you could know after a month, you could have a pretty good idea of how it's performing. And after a year, you could have a really good idea of how it's performing from every project. And then you wouldn't be guessing and you wouldn't need to spend any extra money on M&V if these energy reports are easy to generate and can be easily provided to the utility, and they're all in a standard format that the utility can easily analyze and come up with the magic MMV results. I hope that helped.
Great. Sri is asking, how do you obtain and verify the power data before controls are installed?
That's a great question. Basically, you guess. There are various ways to guess. Some utilities, depending on the resources available, some utilities interview the facility manager and ask them how the facility was used before the new lighting controls were installed. For instance, in this space where the lights turned off at night, in this space where the lights on all the time, in this space where people conscientious and people were only in the space 2 hours a day and they always turned it off. So you can interview and get some sense. In those two studies that I mentioned from 2017 and 2020, we came up with a standard way to estimate. I shouldn't call it standard. We did not publish a standard, but we came up with a uniform way to estimate the power usage before the controls were installed. And that involved taking the occupancy data from the network lighting control system report and basically assuming that whenever a space was occupied before, then all the lights were on. And whenever a space was completely unoccupied, you can assume that the lights were off.
So for instance, if like the first time a space is occupied in the day, that space is then on for the rest of the opening hours of that
Right.
area.
Assume the first person who works into the building flips on all the switches and the last person out switches them all off. So when you do that, you don't get credit for scheduling. If, for instance, if the lights were on 24 hours a day and now the NLC system is enforcing scheduling where the lights are turned off outside occupied hours. So it leaves some of the savings on the table if nobody was paying attention to the lights before. But it still gives you a uniform way to compare the results from various buildings. So if you want more details about how we set up that baseline, please take a look at either one of those two reports. And the more general answer is various efficiency programs have various ways of establishing that baseline energy usage before the system is installed.
And then Kate is asking for more discussion around using kilowatt hours as the energy, as a unit for energy consumption, um, as opposed to watt hours, I believe.
Yeah, so neither one is perfect. Um, be, because in a small space, if you report in kilowatt hours, you're going to have lots of leading zeros and really small numbers. And in a really large space, if you report in watt hours, you are going to have lots of trailing zeros and really large numbers. And so either one is a compromise, but the overriding concern was that there needs to be one consistent number so that each energy report doesn't need to be inspected individually to figure out whether it used kilowatt hours or watt hours.
Right, pick one for the energy report files, and then the individual utility programs can scale as needed based on their own preferences.
Right. Pick one. Now it's a little bit complicated because when we pick one and we go by standards, the C137.6 default is watt hours. Um, and so, but they do have an alternative path to recognize kilowatt hours by using a scalability factor. So we'll have to work that out in the comment period about exactly how to deal with that. But the standard does make space for kilowatt hours. It's just not the default.
Gotcha. All right, well, that's all of the questions we have. Anybody else have any questions? One more from Sri. If the primary goal is savings, can we just not take a reading once per month like our home bill?
That's a good question. That would be a question to take up with the measurement and verification folks in efficiency programs who have a long history of ways that they have verified energy savings in the past. Now, it seems like that would be useful in some situations, especially in cases for, say, a room-based system where a full report, where you know a full report's not going to be available, but something like a once-a-month reading would probably be a lot better than nothing. So actually, that's probably a question for me to refer to Jason, who is working on the DLC's new program for a room-based system. That could certainly be something to consider there. For a room-based system, would something like a once-a-month reading at least be useful, maybe not required, but at least recognized and reported?
Potentially, we'd have to look at that, the details on that, and that would require a cumulative, non-resettable measurement, like a power meter, which we don't really have, which is different than what we've been talking about in this standards. So we'll have to look into that. A couple more questions coming in. John Wilson says, can you talk at all about specific drivers or other hardware requirements for energy monitoring? Is there any idea or rough estimate of additional cost for including energy monitoring?
So the big cost is if you can install the network lighting control system as is without a server, but you need a server on site in order to have energy monitoring, or else you need to, or if it's a cloud server, you have to set up a cloud server. That seems like that can be thousands of dollars. There's also the question of the memory on board the processor. If there's a controller separate from the server, typically the embedded memory and embedded processing power within a small controller is limited. And so requiring, for instance, 2 years of 15-minute interval data is actually a significant burden on the memory, unless it's reporting out to a server, and then you got to have a server. So I don't really. I guess a rough estimate is it can be thousands of dollars, but that's a really rough estimate. I'm hoping with these changes, and if we can find any more changes, to be able to bring the cost down and make it more easily affordable so that it can be included in more projects.
Just incidentally, another factor on hardware and driver requirements or controller requirements is there are two ways to measure this energy usage, whether you actually measure the current flowing through the device or calculate the current that was used by the device based on the number of hours or minutes that it was at a certain level. Actually measuring each device at the control point costs a bit more in components, but has other advantages for ongoing maintenance and reporting features that are beyond energy reporting. So there are trade-offs there either way. Bunch more questions came in. Okay, I see Michael's responded to the question about reading once a month. He says data readings help create saving strategies. Once a month does not give real-time feedback, which makes sense. Roy is asking, are the 2-year daily reports assumed to be daily aggregates of the 15-minute intervals?
Yes, there is, yes.
Kip is asking, how difficult is it to get granular data versus once per month readings? It seems ignoring readily accessible data is difficult to justify in a world where iOS presumes to tell me how many steps I took yesterday. Yeah, so if we have the granular data already, it seems like it doesn't make sense to ignore it.
Yes, I agree. For a fully networked lighting control system, we absolutely need the granular interval data of it at least once a day. Yeah, the once a month read proposal would be in the case of a room-based system that it's either you get that or you get nothing. But yes, I agree. When granular data is available, and especially when the system has access to the internet, so it has access to the world clock, then it's not that hard to get granular data. Turns out the hard part is keeping it. Sending it through the network and then storing it somewhere to be downloaded later.
Right. To that line, Umesh is asking if the granular data is available at the luminaire level, can the dashboard aggregate to come up with group or zone level energy consumption? I think the answer is yes. That's the idea. We want to do that. We're just trying to figure out how to best organize that.
Yeah, and that will probably depend on different manufacturers. Presumably will do that different ways. Some may do more edge computing and some may do more centralized computing. So that's not something DLC would specify. We just need the results wherever it's done.
Right, but we're interested in a uniform way of presenting those results.
Right.
Let's see, a lot going on. Sri agrees with you, Levin. Sri commented that room-based systems are easier and cheaper. Bill, can you tell me timescale DB from Bill Mitchell? Can you tell us more about that? I can unmute you real quick if you are available. I see, just a small database for time codes. Got it. All right. Any more questions? We'll look into Intellimation and see what that is, Bill. Any more questions? Give it just a few more seconds in there. Kip is asking, are greenhouse and other hort facilities included?
Well, not at this time. We are starting to look into controllability in hort facilities, but that's separate from this effort at this time.
Gotcha. And Iman is asking, how can we control the validity of CSV files presented to the utility? And make sure they're not tampered with on the way, I think is what he's asking.
That's a great question, which actually that sounds like a good question for me to put up in the request for comments in the first draft. Thank you for the question.
Yeah. Yeah, we'll look for some feedback on that. Great. I think that's all we've got coming in. So thank you all. Back to you, Levin.
Great. And that concludes the webinar. Thank you for your attention. Oh, and thanks to the many people in this call who have contributed in one way or another to the progress that we've made.
Pamela has a question.
Oh, okay. Well, just in time.
See, we'll wait for that to come up real quick. Pamela is asking, where can I find more information on the white paper proposed revision to DLC energy reporting?
Oh, that was just published Monday. So if you go to DesignLights.org, that is in the, I believe it's in resources. Oh, here, I can go back to that slide, actually. There we are. In resources, reports, and the white paper.
No, I lost on my windows. Great. And I think that's it.
Okay. Thanks, everyone. And I think we're set.